By the middle of World War II, soldiers operating in mobile units, bomber crews, resistance cells and forward observers all faced the same quiet problem. Firewood was unreliable. Wet environments, rapid movement and scarcity made traditional logs heavy, slow to ignite and wasteful. A small fire that burned too hot or too fast could give away a position or exhaust fuel supplies in just minutes. Out of this pressure emerged a compact solution that looked unimpressive but performed with ruthless efficiency. The wax fuel brick, sometimes improvised and sometimes factory-issued, burned longer, steadier, and with greater control than fire logs ever could. This was not a convenience item. It was a survival tool shaped by wartime constraints. The wax brick solved three problems that firewood never could. Firewood fails under three conditions common in wartime. It absorbs moisture, it burns inconsistently, and it requires bulk. Wax-based fuel blocks answered all three. Wax is hydrophobic, meaning it resists water. Once ignited, it burns at a predictable rate. When combined with absorbent filler, it becomes both fuel and structure. During the war, these bricks were made from paraffin wax mixed with cardboard sawdust cloth scraps or compressed paper. The filler acted as a wick, drawing molten wax upward and regulating the burn. This produced a steady flame rather than a sudden flare. In practice, a wax brick the size of a ration tin could burn for hours, long enough to heat food, boil water, or provide sustained warmth without attention. Wax fuel bricks were rarely used as open campfires. Instead, they were placed in small stoves, mess tins, trench heaters, or improvised shelters. A single brick could maintain a low flame that heated metal surfaces without producing large flames or excessive smoke. This mattered for concealment. Firewood crackles and throws sparks. Wax burns quietly. In occupied territories and forward positions, silence and low visibility were, quite frankly, survival advantages. Modern survivalists can, apply this by using wax fuel blocks inside enclosed or semi-enclosed heat reflectors rather than open fires, really maximizing efficiency and minimizing exposure. The reason wax bricks outperformed fire logs comes down, simply put, to energy density. Wax contains more stored energy per unit of weight than wood. And when combined with controlled wicking, that energy is, released slowly. Wood burns from the outside inward and relies on airflow through its structure. Wax bricks, on the other hand, melt internally, feeding the flame gradually. This makes burn time predictable. A properly made brick does not surge or collapse. In wartime testing, wax-based fuels consistently delivered longer usable heat than equivalent volumes of wood, especially under damp conditions. When issued fuel blocks were unavailable, improvised versions were common. Wax came from candles, sealing wax or industrial sources. Filler came from whatever absorbed wax without dissolving. The process was simple. Wax was melted carefully, filler material was packed into a mould, such as a tin can, and molten wax was poured in until saturated. Once cooled, the brick became solid and waterproof. For modern application, this same method can be used, but, with caution. Melt wax slowly, avoid open flames during preparation, and make sure the filler is fully saturated to prevent uneven burning. Another advantage over firewood was safety. Wax bricks produced a low, steady flame that was, honestly, much easier to manage inside shelters, bunkers, and vehicles. Firewood required airflow and space, which in turn increased fire risk. Wax bricks could be extinguished and relit if partially used. Firewood, once burned, was gone. This allowed rationing of fuel across multiple uses. For emergency preparedness, this feature alone makes wax fuel superior for indoor or semi-indoor heating scenarios. Firewood requires tinder and kindling, but wax bricks did not. They ignited easily and, they sustained their own flame. This eliminated the need to gather additional materials, which honestly was often impossible in combat zones. This dual function reduced complexity. Fewer components meant fewer failure points. That philosophy really defined much of wartime field engineering. Today, reducing dependency on multiple ignition stages increases reliability in adverse conditions. After the war, cheap fuel and centralized supply chains reduced the need for compact, long-burning fuel blocks. Convenience replaced efficiency. Fire logs became recreational rather than functional. Yet the underlying advantages of wax fuel never disappeared. They were simply overshadowed by abundance. In emergencies, scarcity returns quickly. When it does, methods like this regain relevance. To use this knowledge now, focus on energy density, moisture resistance, and burn control. Wax fuel blocks can, supplement or even replace firewood when weight, space, or, concealment really matter. Use them inside controlled environments. Pair them with reflectors to, direct heat. Extinguish and reuse when possible. Treat fuel as a resource, not a spectacle. The WWII wax brick was not a novelty. It was a response to real constraints under real pressure. It burned longer because it was designed to, not because of luck. Understanding this method reminds us that effective solutions are often quiet, compact, and unglamorous. If this guide deepened your appreciation for practical wartime ingenuity and durable survival knowledge, subscribe to Backyard Wisdom, share this episode with others who value tested solutions, and help keep these lessons alive where they belong.